I am Narayanan Thivengadarha from Larsen and Toubro Infotech. I have a long name, so when I came to Stockholm in 2011, my Swedish friends started addressing me as TN, and now I am called as TN even within my company and with my Indian colleagues. So you come from? Yeah. So Larsen and Toubro, I think the name rings a bell. We have a very strong Nordic connection because both our founders, Henning Holk Larsen and Soren Christian Toubro, they were from Denmark. The company was founded by them in India in the late 1930s. So, Madam Ambassador, one of the earliest Indo-Nordic collaboration effort. And we are India's largest engineering and construction company right now, with operations in about 30 countries and group revenues of about 15.5 US dollar billions, and also regarded as one of the most innovative companies across the world. And we have diversified into different business sectors, as you can see, right from hydrocarbon to power, to industrial products, to electrical and electronics, to IT, to engineering services, to aerospace and defense, etc., etc. And since we are a very strong engineering and construction major, smart manufacturing is something which is at the heart of the company, and there is a lot of investments and a lot of R&D that goes across. And I represent Larsen and Toubro Infotech. We do IT and engineering services for our customers. Sixth largest Indian IT services company with about $900 million US dollars of revenue, about 226 clients across the globe, about 21,000 employees worldwide. We have offices in about 22 cities and additionally about 42 offices abroad, outside of India. And about 44 of our customers are in the Fortune 500 list. So basically, we are an end-to-end IT services company with a unique business to IT connect, because we understand the manufacturing, logistics, and the financial services business, since we also are from the business side. And we are also a digital transformation partner to many of our customers across the globe. Coming to smart manufacturing, I thought that I can take you down the history for a brief couple of minutes. To understand what smart manufacturing really is, I think we also have to understand how it evolved in the first place. As you can see here, Industry 1.0, that is termed as the first industrial revolution ever in the history of mankind. And that was possible in the late 18th century by the invention of steam engine. So steam and water became the primary drivers of the economy, of the manufacturing processes, and from this derived were railways and so on and so forth. And this ushered in a lot of increase in productivity and huge development and also wealth creation. And then came the second industrial revolution. We had to wait about 1 century. So this came in the late 19th century, early 20th century, when Henry Ford started the assembly line and started manufacturing the famous T model in the US. And here the primary driver of this was electricity, because by that time electricity was widely available and adopted across the globe. And then this also ushered in an era of mass production. And then about 1 century later, in the late 20th centuries, we had the third industrial revolution, and that was enabled by electronics and IT in the manufacturing process. And here the primary drivers were automation, PLC and SCADA, as we term in the technical jargon, but along with it also came the internet revolution, the WWW. And then that was also an era of tremendous productivity increase across the globe. And then the fourth industrial revolution, we now call it as Industry 4.0, is happening right as we speak. And here the primary drivers are connected devices that we use in our daily lives, not only in the manufacturing, not only in the shop floor, but right here in our offices, right here in our homes, and so on and so forth. So here what we have, the primary driver is the interaction between physical devices, the microprocessors, the microcontrollers, so on and so forth, to the digital world, that is data analysis and cloud and data transformation services. And then along with it is the Internet of Things. That is, we have connected devices. Every device, every microprocessor is connected online with wireless technologies. And then we have a seamless network of connected devices across the factory, also across the globe. And here, the primary thing, if we notice here, is that all the other three industrial revolutions, we had to wait about 1 century. And this is, within about 20, 30 years after Industry 3.0. And the way this is going to transform our lives is going to be phenomenal. As an analogy, if I take, for example, in our lives, not long ago, we still used camera films. We used to buy films in the shop. It has about 36 clicks or 40 clicks, and then we used to develop it into a negative and then print. And that's how photography was done. And then came the digital cameras and so on and so forth. And people started thinking that, oh, so how nice this device is. You can just keep clicking and put it on the computer, and you have the photos and email and so on and so forth. And now we have the wonderful smartphones. And now nobody uses digital camera, of course, SLR still survives. But then you are directly connected. You directly take photographs, put it on the internet, Facebook, and so on and so forth. So that's how it's going to change. And perhaps, maybe a few India Unlimited events down the lane, maybe we'll be saying that once upon a time, there were cars that was driven by people. So that's a pretty brief background about Industry 4.0. I'll quickly take you through about the components of smart factory and the Industry 4.0 revolution that is taking place. So the core of the smart factory is the cyber physical systems, that is the connected devices, interactions, and so on. And then we have the broader concepts like digital manufacturing, we have Internet of Things, devices connected, talking to each other, real-time data processing, and then how do we analyze this data and then make meaningful sense out of it, comes from analytics or the predictive models. And then we have the social web, social media and networking, where we also get real-time data of the market and then channel it back to our R&D efforts and so on, so that we can be more responsive to what customers are talking about our products and services. Smart maintenance, this is something which is going to gain a huge momentum as we go forward, because this is an area where we also deliver services real time. For example, for instance, if you have a smart car, for instance, and then there is going to be a software upgrade that is needed. Perhaps there is a fix that is needed to the suspension system. In the earlier days, we had to go back to the dealer, fix it. So that requires a lot of time and effort and money. Whereas here, this can be done directly on the fly if the car is connected. So that's what we are talking about, smart maintenance. Robotics in the assembly line, which will increase productivity. 3D printing is gaining a lot of momentum. In the days to come, it will increase. Smart grid, where we have interconnection across the factory and the customers. Service integration, so we aggregate a lot of services and then take it on to the market with packaging differentiation. And then coming to the connected floor and big data and velocity, embedded, machine-to-machine or M2M communication, that's also going to be at the heart of the manufacturing process, and that forms the smart factory. But then, what is the way ahead for smart factories? Is it something that, can I postpone my investments? Can I just see how this takes up and then go forward? Really not, because this is something which is going to be really, really transformational, because world is changing so fast. Improvements through smart manufacturing, increased efficiency, shorter time to market, increased flexibility of products, and then producing products and servicify. That is, we talk not about great products, but great services for the customer. And then we have to be careful here, because smart manufacturing is not just about technology adoption, because technology is just going to be an enabler. It is about how do we collect data, how do we analyze data, digitize it, and then use it for the benefit of our customers. And at the same time, with an India Focus initiative, how can we make it more affordable to people? But of course, there are challenges, because cybersecurity is something that we have to be careful about. Intellectual property rights is going to be an issue, and also the IT infrastructure and skills in India. Just a concluding slide here. Industry is receiving a major fillip, Make in India initiative, industrial corridors and smart cities, and this has to be viewed in terms of the smart manufacturing and the way India is developing its highways. It all started in 1998 by former Prime Minister Mr. Atal Bihari Vajpayee. At that time, we never actually thought that we could have such beautiful highways in the country. It is maybe we can draw a parallel to President Eisenhower's 1950s highway development plan in the United States. Manufacturing contribution is going to go up, and that's where we need to also become smarter in the shop floor. And Sweden ranks high on technology and innovation. And then the bigger question is, how do we adopt this technology and innovation, make it affordable, and then take it to the common man so that we can uplift a lot of people across the spectrum in India. And of course, going down the lane, we have a lot of collaboration between India and Sweden. A lot of Swedish companies have their manufacturing firms in India, but then the next wave is, how do we jointly co-create services, jointly do research and development, so that we can actually co-create value for the customers and for India and for Sweden. Thank you so much.